Alright, let's try to solve some more exercises. And today we have characters, bools, and units. Now, a character in Rust is a 4-byte Unicode character. So basically, we can represent letters of English, or we can also represent other languages, for example, Chinese language, or you can even represent emojis. Now, in this exercise, we are trying to compare the size of the character with 1. So basically, this particular function is going to return the size of this character variable, and then we will have this with 1. Now I just told you that a character is a 4-byte value, so basically this is going to fail. So let's run this program and see for ourselves that it will fail, and it does. And see, exactly, this is telling us that, well, the left side of this particular macro is 4 and the left side is 1. So what we have to do is enter the correct value. Now if you run this program, this is going to fail on this particular statement, and the reason is simple because again this is trying to compare the size of this variable to 3. Let's also correct this and run this exercise. Now this is going to print success. Let's move on to the next exercise. Let's run this and see what the error is, and you will see that it expects a character. So let's try to go through this program. So this is defining a variable c1 and is storing this particular character, and then we are printing this character. Now the print character function takes c as the argument of character type and then prints it. But the problem here is that we are using double quotes, and if you don't know, double quotes are used for creating a string literal. So let's correct this, and we shall see that this will now print this particular variable. When we define a character, we need to use single quotes rather than double quotes. The next data type is bool. Bool is a single byte value. In order to define a Boolean type variable, you have to write bool. And let's try to run this program first. It prints no output. The reason is because we are trying to compare that if t is not true, then print success. But here we have t is true. So let's try to change this and force it to print success. And yes, it is. Now this is also going to fail, obviously, because we have to fix something in every exercise here. It says that the left hand side, that is t, is false, and right hand side f is true. So let's try to go through this program. We have f, which is true, and then t has true and false. So basically this is going to evaluate to false. Now we are trying to compare false with true, which is obviously going to fail. So there are many ways, but let's see if it works. It does work. So I'm doing nothing. I'm saying that if t is false, I am comparing it with not f, that is when f is not true, and we know f is true, so this will evaluate to false. So this is an interesting type in Rust programming language, and what we see here is that we are defining a variable, and instead of giving it a type, we are giving it an empty brackets as a type, and then we are storing empty brackets. This is known as a unit type. The unit type data type has only single value. This is the only value that it can take. So when we try to assert equal v with the return value of this function, this is going to fail. I will explain you in a bit why. Yes, it does fail. The reason is simple. What this is doing is making a tuple or tuple, however you pronounce it. This is not empty. Therefore, this assertion fails. So what we have to do is remove everything from it. Now the question arises, why do we need it? Why do we need something so trivial? Well, there are times when you have a function, something like this, and it doesn't return anything. But what Rust does is it returns actually something, and that something is the unit type. So when this function is run here, this particular function is run here, what happens is that it does what it does. It prints this particular string, and then it returns something like this, an empty bracket. And this empty bracket is compared with this particular variable, which is in itself the unit type. Even though not accurate, one way to understand this is that it's similar to void in some aspects, but not exactly void. Look, a void in C++, for example, it doesn't return anything. It just gives control to the caller itself. But in Rust, what happens is that it always returns something, and that something is the unit type. And if we now run this program, it should print success, because now we have removed everything that was inside. So this is a unit type value. The next exercise is we are trying to get the size of this particular variable, and we are comparing it with 4 bytes. Now here is a good thing about unit type. It doesn't have any size. Firstly, run this program, and then we will change it to 0, and then run the program. It will print success because a unit type doesn't take any memory. And in the next video, we will study something, a really important topic, statements and expressions. See you soon.